In section 5, we're looking more at angles. Now we're looking at how multiple angles have relationships between each other. The first pair of angles that we're going to be looking at are adjacent angles. Now, adjacent angles mean they are sharing a common ray. But the ray that they're sharing has to be the ray in the middle. The one that they're sharing is in the middle, so that if I have the two angles, they're adjacent if the interiors do not cross. So I have a yellow angle, I have a blue angle, they don't cross and make a green angle. The next pair is a pair of vertical angles. Now, vertical angles are angles when we have two lines crossing, okay, so two intersecting lines. We end up with four angles, and if you notice, angles 2 and 4 or angles 1 and 3 are across from each other. Those are our pairs of vertical angles, the ones that are across from each other. In the same picture, we also have what's called a linear pair. So if I look at my line A to B here, and I look at two angles that are beside each other, so angle 1 and angle 2, angles 1 and 2 will come together to create a line. And so they are adjacent, and the sides that are not touching each other form a line. Next thing, you should have seen these before. Complementary angles add up to 90, so we're going to get a right angle when we add 1 and 2, but they don't have to be together like this 50 and 40 degree angle. These would still be complementary. We just need to have them add up to 90. Same thing with supplementary angles, except they need to add up to 180. We also have perpendicular. Perpendicular lines form to make a right angle, which is just 90 degrees. So if we have perpendicular lines crossing, we get 4 right angles. We usually only mark 1, but we could mark all 4 of them as being right angles. We use a little square mark on that to identify that those are perpendicular. We also write that lines are perpendicular in this way. We read this as line XZ is perpendicular to line WY. We can also use the same symbol with segments. I could say segment WY is perpendicular to segment XZ. We can do the same with rays as well. In this problem, we want to find x and y to make this perpendicular. So what we should recognize here is that these two angles come together to give me 90 degrees, so that 6x and that 3x are going to be equal to 90, and we would just solve our equation there to find x. We would do the same thing with the 12y minus 10 to set it equal to 90 degrees to make it perpendicular. Now, if we're talking about perpendicular to a plane, we're talking a little bit about something else. Just imagine holding your pencil on your desk so that the pencil is sticking straight up out of the desk. That's kind of the idea behind perpendicular to a plane, is that it's going to be perpendicular no matter where you look. So if I choose any point in the plane, like going from A to C, then BAC would form a right angle. Or if I wanted to go from B to A to E, that would also be a right angle. It doesn't look like a right angle in this picture, but that's because it's all about perspective. And if we looked at it closer or laid that plane flat, we would see the right angle. Now, this next part is pretty important because we're going to see a lot of pictures in our class, and we have to know things about that relationship that we're allowed to assume and things that we're not allowed to assume. So the first thing I need to look at, usually we're going to be dealing with things that are in a plane. It's important to just know that this thing's going to be coplanar unless they give us some other information that says we have multiple planes. So usually we don't have to worry about things getting mixed up. Now the next thing, notice here at D, it looks like all of these lines and line segments are crossing there, and so we can assume they are. They're not saying that this is happening like really close to D, but they can't trick us like that. They're just going to say this is at D. We can also say, since this here looks like a line, it's a line. If they're going to tell us it's not a line and they're going to make an angle, they can't just say it's 179 degrees. They need to make it look like it's an angle, or be very clear about that in some way. So if it looks like a line on the picture, we are allowed to assume that it's a line. We're also allowed, in this one, B is the interior of ADE. So if I look at angle A to D to E, We can see that B is in between there on the picture. And it is important that we assume that because we don't really know how big ADE is, but we can see that B is between there, so we can say that it's on the interior. For CDE is a straight angle, so this kind of goes back to it being a line, so it's also a straight angle. Adjacent angles, so since we have CDA and ADB, we see that those go together. They're only sharing one side. And then the other parts are just talking about, again, that this is a line, so they form a linear pair, and then that they're also supplementary. They would add up to 180 degrees. Now, there are also things that we can't assume about this picture. It might look like CD and DE are the same length, but we don't know that because it wasn't marked. And so we can't say CD equals DE. Same thing with our angles. It looks like they're the same size, but unless they tell us they are, we can't assume it. Again, it might look like this is a 90-degree angle, but if they didn't tell us, we don't assume it. It might be really close. Now, if we do have these markings on the bottom, then we would know this is true. So I have markings for congruent angles, little arcs. I have markings here to show the segments are congruent, and I have a right angle marking, and then it's okay. So real quickly, if we look at this picture, GHM has angle markings, and angle MHK. If we look at these, they're asking, are they adjacent angles? We can see they share a side, so yes, they are adjacent angles. For KJ, HJ, and GHM, so we look on our picture where those are, K to H to J, G, H, M, it asks if they are complementary. Well, the answer here is we don't really have enough information. Actually, we might have enough information to say no for sure, but what we can see between these is that they are congruent, not complementary. GHK and so G to H to K and J to H to K. We put those two together, notice that we're getting a linear pair there because they are forming a line on this side. Those two angles are coming together to give us a line. So yes, that is a linear pair.